let's look at f of x equal minus 2 x squared plus 5. I want to prove that this is even, odd, or neither, okay? So if I'm going to do that, I'm going to have a chart. You'll be given one on your test that has 3 different things on it. Okay, something that looks like this. Okay, and then what do I do? Yeah, so the first one, you should be able to copy this one down. This is negative 2x squared plus 5. That is f of x. Then I need to find what? Yep. Okay, then, I mean, but what do I do next? Like, instruction-wise, what do I do? Right, I got to find f of negative x. So what I always did, I always just did f, and I always replaced this x with blank parentheses. So this is negative 2. I only replace the x with blank parentheses. Okay. So I wrote down f of x, but everywhere there was an x, it got a blank parentheses, and that's what I'm going to be substituting in. So what gets substituted into those parentheses? Negative x. So negative x, negative x. And then I have to do what with this? Am I done? No, I've got to see if it simplifies. I'm trying to see, does it equal this or the opposite of that? So I got to work on this right here, okay? So what is this? This tells me that f of negative x is negative 2. What is negative x squared? How do you square a number? What do you do with a number when you square it? Multiply it by itself. So this is negative x times what? Negative x plus 5. Okay. Now what have I got? I've got a negative 2, a negative x, and a negative x. What are those 3 negatives are going to give me? A negative. So I'm going to have f of negative x equal negative 2, what? X squared plus 5. Now what did I just show then? What have I got? This is an even function. Okay, so this function is even. Why is it even? Yeah, because f of x equal f of negative x, and I'm done. Okay, so I don't need to go prove that it's odd or not because I just proved that it's even. So if these did not match, then I would need to go see if it's an odd function. Okay, so once you get one of these to work, then you know that's what it is. It's an even function. Okay, so like I said, this is probably the toughest part of this unit. Because each problem can be presented a little bit differently, and you just got to work through the algebra for that. Okay, so on to our dance party. You might be a little bit underwhelmed. The question was why they have teeth. I don't know. I was just making that, so I don't know if that makes them look like zombies or goofy or what. So we have 6 functions that we've got to remember. Okay, so this one's going to be a touchdown. Why is that a touchdown, Jacory? Why do we call this one the touchdown? Why would I call this a touchdown if I had a function that looked like this? Pretend like you play football. What is this? Touchdown. That's why we call it a touchdown. You know, so we've got one function that looks like this. I'm just going to say that's a touchdown. If I hold my hand straight out, this one I'm calling a V. Why do you think I'm calling it a V? Your hands look like a V, okay? I didn't name some of the others. Some of the group last year named them. I've got one function that looks like this. You want to call that the push? What is it? Superman, okay? So this one we'll call this one Superman. And then I think I call this a seagull. It goes out like this. I can't think of anything better for this. You can always change it in your mind. So that's different. I mean, this one is the V, but one that goes out like this. the seagull. And then the other two we've got one, and we'll look at these graphs. X cubed is going to do like this, you know, and then so X cubed, this one up here, it's going to look like this. It's well, you think of like, look at it like this. So this arm goes up, something like this, maybe like this. Okay. So I don't know what you want to call that one. You want to call that the Egyptian? Because we've got that one, and then we got another one that does this. We got one that does this, and one that does this. Which one do you want to be which? This one is the Egyptian. Okay, this one is the Egyptian. I got to try to remember these, and you're calling the other one down here a wave. The one right here, calling that a wave. Okay. So I think one of them, I think they called that a pump last year, or this one a pump. I don't know. I can't remember. Anyway, you don't have to remember these names. You just got to know what they look like. Okay. So we're going to make associations. And these are the dance moves. Feel free to use them on Friday and Saturday night. They will not win you friends. So let's take a look and let's do a few graphs here. Okay, so what we're going to do now, I'm going to work through these graphs by plotting points. But you should get so familiar with these graphs that you don't have to plot points, that you know, like, when you see x squared, it's a touchdown, and it looks like this, okay? You don't have time to plot points every time because we're going to start moving these graphs around. But if I want to graph f of x equal x squared, I plug in an x, and that's my input is x. My output is what? X squared. So what happens when you square negative 2? 4. When you square negative 1? 1. When you square 0? When you square 1, and when you square 2. So I need to plot these points. These are my x points, and these are my y points. Okay, so let's plot negative 2, 4, which is right here. Negative 1, 1, 0, 0, 1, 1, and 2, 4. So I just plotted each of these points, and then I play connect the dot. This is the one that we called a touchdown, okay? Well, no, there's another one's going to look more like a V. So this is rounded somewhat. So this is our touchdown, okay? So when I say x squared, this is the dance move you hit the floor with, okay? So this is what x squared is going to look like. Let's talk about some properties of this function, okay? So this has a function, this has a point called the vertex. Where do you think the vertex is? Yeah, it's where? What point is it? 0, 0. So this point 0, 0 is called the vertex of this graph. I want to make this a little bit smaller so we can get more in here. Now the domain is the set of all x values. Okay, so we read the domain, the set of all x values. Which axis do I need to look at to find x values? Not a trick question. The x-axis. Okay, so I look and see. Okay, what do these arrows mean on this function? It's just going to keep on going forever and ever. So this is going to keep on spreading out. So it's going to keep on spreading out forever and ever. So my domain starts where? Negative infinity. Okay, so it's going to go from negative infinity to positive infinity. So what's going to happen? This function is just going to keep on spreading out like this. So even though you don't see a value here for x, this is just going to keep on going out further and further. So my x values are going to go from negative infinity to infinity. That's my domain. Now, the range is the set of all y values. This is the only time we will ever look at the y-axis to get an interval of numbers. Okay, so the range means y values. So look at this function. I'm on the y-axis. Are there any y values on this graph down here? No. If I travel up this axis, I don't see y values until I get to where? 0. So that is my first y value, is 0. Is it included in the graph? Yes. So this is a square bracket. Okay. So here's 0. Now let's just keep traveling. How far up will I keep going and getting y values? To infinity. Okay. And I put a parentheses around that. So the range of this function is 0 to infinity. Okay. Does everyone see? So the domain, I look at the x-axis. I always start over here to the far left. The range, I look at the y-axis, and I start at the bottom and see what values I have. Now, intervals where this function is greater than or equal to 0. Okay, every other time I ask for interval, it's going to be on the x-axis. So we did this on the previous quiz. So where is this function greater than 0? I'm looking above the what? Which axis? Above the x-axis. Okay, so if you look at above the x-axis, that looks like to be where on this graph? So I start over here. This is everything that's above the x-axis. So if I start traveling over here, are my function values above the x-axis? Yeah. And I keep traveling. They're always above the x-axis, right? So the interval, the x-interval in which this function is above the axis is from where to where? Yeah. So this is from negative infinity to infinity. Intervals where this function is less than 0. That means I'm looking, where is this function below the x-axis? Does that happen? No, there's none. Okay. There are no intervals where this function is below the x-axis. Now, the other concept we need to talk about is something called increasing or decreasing. Okay, I think it's fairly intuitive, but let's just make sure. To tell if a function is increasing and decreasing, we always travel from where to where? Left to right. So if I start traveling from left to right, so let's just mark a couple points. Let's just say that I'm right here on this function, okay? And I keep traveling from left to right. So if I travel from here to here, okay? If I travel from left to right, those green dots, did they go down or did they go up? They went down. As I was traveling from left to right, the values went down. So that means this function is what? Decreasing or increasing? Decreasing. So this function decreases from, and I asked for increasing, but let's just get the decreasing. So this function decreases from negative infinity until it gets to where? Yeah, as I travel on the x-axis, it's decreasing from negative infinity to 0. So it decreases from negative infinity to 0. Your increase and decrease will always be parentheses, okay? Because it's decreasing over an interval. It doesn't make sense to say, is it decreasing at a point? Well, at a point, there's no movement happening. So it is always, when you look at an interval for increase or decrease, it is always parentheses, never any square brackets. So then where is the interval where this function increases? Yeah, 0 to infinity. So if you look at this, as I travel from left to right, this function is decreasing from negative infinity to 0. Once I get to 0, this function starts increasing. Because if I travel from here to here, if I mark a couple of points, as I go from left to right, did the points go up or down? They went up. So it is increasing from 0 to infinity. So you can see I get to where I can start to ask a lot of questions about these graphs by adding this domain and range, increasing and decreasing. Is this function even, odd, or neither? It is even. Why is it even? You look at it, it's symmetrical about the y-axis, okay? So this is a function that is even. And there we go. So that is our first dance move. We called this one the what? Touchdown, okay? So anytime I say x squared, it's going to look like this, okay? So we're going to have 6 functions, and we're going to move them around. We're going to turn them upside down. We're going to move them left and right, but they're all going to be based on this. So anytime you see x squared or something based on x squared, the shape of that graph is going to look like this. Now later we'll learn, instead of this, it may do this, okay? But it's going to be based on the same shape, okay? So that's how you get the movement of the dance in. When it's x squared, that's negative x squared, okay? So does that feel okay? Is that okay? You've seen this before, right? Okay, at some point. So let's look at another one of our functions. X cubed. This is the one that looks like this. So we call this one what? The Egyptian, is that right? So it's something like this. You got to make a difference between, there's one that goes off like this and there's one that goes up like this. So this is the one that's x cubed. I think we call this one the Egyptian. So it's doing something like this. Okay. So the general shape is going to be something like this, but we'll graph it. So what happens when you take -2 and you cube it? What do you get? -8. -1 cubed. -1. 0 cubed. 0. 1 cubed. 1. 2 cubed. 8. So we need to graph all of these points. -2, -8 is right here. -1, -1. 0, 0. 1, 1. And 2, 8. So what I can see this function doing is something like this. Okay, that's where I get this shape from, okay? So this is our Egyptian, as we called it. Now this point doesn't have a vertex like the parabola did, the x squared, but it has a point called an inflection point. So it's a point where it looks like it's curving this way, and then it starts curving the other way. What point do you think that is? 0, 0. So at the point 0, 0, we call that an inflection point because our graph looks like it looks like it's arcing this way, and then it goes to arc the other way. That happens at 0, 0. The domain is the set of all x values. So keep in mind this graph, even though it's doing this, it keeps on going in this direction. How far? Forever and ever. This direction, forever and ever. So it's forever and ever in which directions? Both what? X and y, okay? So what is the domain of this function? Yeah, this is going to just keep on going forever and ever. So it's going to be -infinity to infinity. That's the domain of this function. The range. The range is the only time you're allowed to go to what axis to find your answer? The y-axis. So go to the bottom of your y-axis. What is the smallest number this function takes on? What is it? -infinity. Keeps on going forever, right? -infinity, and it keeps on going up till it gets to where? Positive infinity. The range of this function is -infinity to infinity. Okay, so the range is the y-axis. See this arrow that just keeps going? This is going to keep on going. It's going to keep on going off in that direction and this direction. So the range says go to the bottom of your y-axis. These values are going to keep on going. The smallest number on y is -infinity. Keep traveling up the y-axis, it's going to keep on going forever and ever. So your y values go from -infinity to infinity. Now that's different than the one before. So remember x squared that we just saw, when we went to find the range, we were down here at the bottom of the y-axis and there are no values. So as I travel up the y-axis here, I don't get values until I get to 0. That's why this one is 0 to infinity. Okay? So again, just be sure to acclimate yourself if it's domain, x-axis, range, y-axis. Question? Okay, yeah. Intervals where this function is greater than or equal to 0. That means I'm looking where is the graph above the what? Which axis? Above the x-axis. So where is it above the x-axis? That's from there to there. So where is that interval? Remember these intervals are, I'm always on the x-axis unless I ask for what? The range. So the range is the only time you start on the y-axis. Everything else, this interval says look at the x-axis. So it's not above 0 until I get to where? 0. So it's from 0, it's greater than equal to. So it will be above 0 from 0 to where? Infinity. Okay. So this part where it's greater than 0, less than 0, this is stuff we did in the last assessment. Intervals where this function is less than 0. Where is the graph of this function below the x-axis? Again, start traveling from left to right. If I start traveling from left to right, is the graph below the axis in this part? Yeah, it's below from where? -infinity until it gets to 0. So from negative infinity to 0, always a parentheses there. What kind of a closure goes around this 0? Parentheses, because you see less than. If this had been less than or equal to 0, this would be a what? A bracket, okay? Now, intervals where this function is increasing. So as I travel from left to right, okay, so if I mark a point, so if I'm traveling from left to right, suppose I'm at this point, and then I travel further and I get to this point, what's happening as I travel from left to right? Are the values going up or down? Yeah, so it's going up. This one, do you ever see it going down? No, so as I travel from left to right, wherever I am, as I keep going to the right, I keep going up and up and up. So this is going to be increasing from where to where? Negative infinity to infinity. If it's increasing from negative infinity to infinity, where do you think it's decreasing? Nowhere, okay? This function doesn't decrease. To decrease, I would have to be able to mark a point on the left, mark another point, and see that the graph went down. This one just keeps on going up. So it is never decreasing. So there are no intervals that do that. Is this function even, odd, or neither? Why do we know it's odd? It's doing the opposite things. So it's whatever I did. So over here, 0, 0. This was the 1, that's negative 1. The other number was 8 and a negative 8. So we know that this is an odd function. Okay. Okay. The absolute value of x. Okay. This is the one that we call, this was the v. Okay. This was the v. So you can certainly work, Michaela, you can work this one in. I mean, huh? Yeah. Okay. Absolute value. What does absolute value mean? You do what? Whatever number is, you make it positive. So what's the absolute value? Absolute value of negative 2 is 2. Absolute value of negative 1, 1. Absolute value 0, 0. Absolute value of 1, and the absolute value of 2. So these are the points that I plan to plot. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. Okay. And if you connect the dots with these guys, it's like this. Okay. Now this is the one, somebody said that the touchdown looked like a V. Well, no, compared to that, this one is the V. This one's just straight out, okay? So this would be me on the dance floor. This would be my move, you know, just just straight out there, okay? So let's look at the properties of this function, okay? This one has a vertex. What do you think the vertex is? 0, 0, okay? The domain, the set of all x values, okay? So if I chart traveling from left to right, what kind of x values do I get on this plot? What are the x values? It keeps on going. How far does this keep going? Forever. Yeah, so the x values are going to be negative infinity to infinity. Okay. Range. Only time ever I make you look at which axis? Y-axis. So you go to the bottom of the y-axis. Yeah. Are there any values of the graph right here? No. I start traveling up this axis, and I don't see any values until I get to where? 0. So the range starts at 0. Does it include 0? Yeah, so there's a bracket. And then as I keep traveling, I will get y values until I get to where? Infinity. Okay, so that's the range of this function. You're just pulling that graphically by looking at the graph. Intervals where this function is greater than or equal to 0. So if you look at it, where do you see it being less than 0? Nowhere. So it's going to be greater than 0 where? I mean, which? Everywhere. So if I start traveling left to right, I'm above the axis. So where it's greater than or equal to 0, that's negative infinity to infinity. Where is it less than 0? There are no intervals for that. And then where does this function increase? So if I start traveling from left to right, what's it doing initially? Is it increasing or decreasing? It is decreasing. It doesn't start to increase until I get to where? 0. So it increases from 0 to infinity. Okay? So it increases from 0 to infinity. Intervals of increase and decrease are just always parentheses. Where's the interval that this thing decreases on? Yeah, negative infinity to 0. So you guys have got this. Yeah, this is even or odd. It is even because it is symmetrical about the y-axis. Okay, so this one, what's the graph? What is this one? This one is what? Touchdown, which is what? X squared. This one is the v, which is absolute value of x. This one, the Egyptian, which is also what? X cubed. So on the test, I'm not going to be grading for the words Egyptian and v or whatever. This is just something to help you. So I'm going to look at, on the test, you're going to say that's x squared. That's absolute value of x. That's x cubed. Okay? Yes?
So for the part where you said that all the points are above 0, how is it all above 0 if you're on the negative? Are you looking at it?
Which one? This one? So where is this function greater than or equal to 0? Where is it above the x-axis? That's everywhere. There are no values down here. So that interval, as I start traveling from left to right, this graph is above the axis from negative infinity to infinity. So it is always greater than or equal to 0. If you think, what does the absolute value mean? It means what? Positive. So I'll never have negative values with an absolute value graph. Okay, so it's always going to be like this. Okay, so that's what the v function does for us. And let's move on. What is this one? This is what? Okay, but what, the mathematical symbol is a what? Square root of x. So this is the one y'all call Superman, the one, this one? Okay, so what is the square root of 0? 0. What's the square root of 1? Square root of 4. Square root of 9. 3. So I need to graph all of these points. So 0, 0. 1, 1. What is it? 4, 2. And 6, 7, 8, 9, 3. Which is right there. And then I connect these dots. So that's what this graph does. So this is our Superman. Okay. Now, this one doesn't have a vertex, but it has something called an endpoint. What do you think the endpoint of this graph is? 0, 0. Okay. Now, the domain. When I look for the domain, which axis am I on? Yeah, I'm on which axis? For domain, x. Are there any x values over here? Like when I'm traveling here, are there any values? I don't see domain values until I get to where? 0. So this domain is from 0 to infinity. And it includes 0. The range. The only time you will ever go to where to look for your values? Y-axis. So you go to your y-axis. Are there... Pardon me? Well, because this point is included in the graph. The square root of 0 is 0. So 0, 0 is a part of the graph. If this had been an open circle, it would not be included. Okay. Now, for the range, are there any values of the graph down here? I don't see values until I get to where? 0. So the range is 0 to infinity. So this one, the range is 0 to infinity. Intervals where this function is greater than or equal to 0. So when I'm looking for intervals that is greater than or equal to 0, I'm looking where does it lie above the which axis? X-axis. So as I travel from left to right, I'm no longer traveling on the y-axis. Why? When's the only time I do that? When you see the word range. Every other interval is on which axis? X. So I'm traveling from left to right. Are there any values of this graph above the axis? No, I don't see them until I get to where? 0. So it is above the axis from 0 to, from 0 to infinity. That's where it's greater than equal to 0. Where is it less than 0? As I travel from left to right, where is it below the axis? Nowhere. Now, where is it increasing or decreasing? Yeah, as I travel from left to right, so if I were to mark a spot here and then mark a spot here, as I travel from left to right, did I go up or down? I went up. This graph is always what? Always increasing. So it increases from where to where? From 0 to infinity. Intervals of increase and decrease are just always parentheses. You don't ever have to worry about brackets on intervals of increase or decrease. If it's increasing from 0 to infinity, where is it decreasing? Nowhere, because that was all there is. So there are no intervals that do that. Is this function even, odd, or neither? It is neither, okay? You know it's not symmetrical about the y-axis, and it's not symmetrical about the origin, so this is neither even nor odd. So this one is, we call this what, Superman, and that's our square root of x, okay? We can, okay. Why do you think it's 6 pages? There's 6 functions, okay? So, now, we've got to take a little care with this one. This is x to the 2/3. What does it mean to have x to the 2/3? What does that mean? Well, I mean, you can't plug in x to the 2/3 on a calculator. So, but I mean, if you just plug in x to the 2/3, you're not going to. So here's the deal. This means the cube root of x squared. Okay? Anytime you see, guys, anytime you see a fractional exponent, the bottom of that exponent means cube, the root, and the top of it just means the power that I'm raising this to, okay? So this means I'm taking the cube root of this number, and then I'm going to what to it? Square it, okay? That's all this really means. Take the cube root of something, and then square it. Let's start with here. Okay, so what this means is the cube root of x and then squared. So let's start here at the bottom. What is the cube root of 8? 2, okay? What happens when you square 2? Okay. So this one is 4, okay? What is the cube root of 1? 1, because you can multiply 1 times 1 times 1 and get 1. What happens when you square 1? You get 1, okay? What's the cube root of 0? And when you square 0, you get 0. These are pretty easy. Cube root of -1. What number can I multiply 3 times and get -1? That's -1. What happens when I square -1? You get 1, okay? Cube root of -8. What number can I multiply 3 times and get -8? That's -2. What happens when I square -2? You get +4, okay? So in this one, you're not going to have to be doing a whole lot of calculator stuff. If you start to memorize what the function looks like, this one is the one we said was the seagull. You'll see this. So -8, 4. So 1, 2, 3, 4. -1, 1. 0, 0, 1, 1, 8, 4. What you see this function doing is this. Okay. So it's a little bit different than the v. The v was straight lines, okay? This one has a little bit of a curve to it, okay? This is what x to the 2/3 looks like. So in this point, let's talk about what the special points are on this graph. This one has a vertex. What is the vertex on this one? 0, 0. Okay, that's that point that it comes to. What is the domain of this function? Okay. -infinity to infinity. This graph just keeps on going forever. Okay. What's the range of this function? Yeah, the range. Remember, I keep saying this over and over. The range is the only time you go to the y-axis to start getting your answer. There are no y values on this function until I get to 0. So the range is 0 to infinity. It's a parentheses on infinity. What goes around 0 here? A bracket, because it's part of the solution. Okay. Intervals where this function is greater than or equals 0. So I'm asking, where does this function live above the what? X-axis. Okay. Yeah, so I'm back on the x-axis because the only time I'm allowed to come down here is when I ask for what? When are you allowed to come to the y-axis? Range. If I'm not asking for the range, you are not on the y-axis, okay? So where is the function above the x-axis? That's from what? Negative infinity to infinity. If that's where it is above the axis, then where is it below the axis? What intervals is it below? None, okay? And then this function, if you look at it, as I travel from left to right, what is the function doing? Increasing, decreasing, y. So as I start out, it's doing what? It is decreasing until I get to, and when I get to 0, it starts to, yeah. So the interval where it is increasing is what? What's the increase interval? 0 to infinity. Always parentheses. What's the decrease interval? Yeah, negative infinity to 0. Even, odd, or neither? This function is even. How do you know it's even? Symmetrical about the y-axis. So which one was this? This is what? Absolute value of x, okay. I'm looking for the math. You can use the name in your head or whatever, or give me that. So I'm really looking for, this was the absolute value of x. What was this one? S squared touchdown. And then what was this one? X to the 2/3, okay. What is this one? Yeah, Superman square root of x, okay. And did I get them all so far? Oh, yeah, this one. The Egyptian, which is what? X cubed, okay. So we are almost there. Let's do one more and we would be through all the functions. Now, what I'm going to let you do is, I've set aside 2 days for us to get through this. I wanted to get through all 6 of them, so you have them. Your homework is for you to just go through exactly what I did here. Without looking at your notes, I need you to be able to walk through what I just did. You saw me do it. Pick points, plot it, answer the questions. I need you to be able to do that. So you can work on, there's 6 of them. You can work on a few of them tonight. When we get back together, I don't see you guys till Monday. We're going to still stay in this topic, and we've got an online game we'll play where you answer questions about even and odd. And then we have a review for our quiz coming up. So let's get through the next one. X to the 1/3. What does this mean? X to the 1/3. What does that mean? It means the cube root of x. So you might see it written like this. So be prepared that you may see it written like cube root of x. That's all this really means, the cube root of x, or x to the 1/3. So what number can I multiply 3 times and get a -8? A -2. Cube root of -1. -1, because -1 times -1 times -1 equals -1. Cube root of 0. 0. Cube root of 1. Cube root of 8. 2. Now I go plot these points. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And then when I go to connect these dots, I see something that looks like this. One of the temptations when you draw this is to, is to make it look like this. It's not leveling off, okay? It's going to keep on going. As you keep taking the cube root of numbers, it's going to keep growing. So this keeps going negative infinity, infinity in all directions. So this one doesn't have a vertex, but like x, what does this one look like of the ones we did so far? This was the Egyptian. This was which one? X cubed. And then all I've done for this one is what? I move my hands out a little bit like this, okay? So the other one it sort of went like this. This one is going like this, a little bit sideways. So if I were to turn this around, That way it would look like x cubed. So this one has an inflection point. Where's the inflection point? 0, 0. The inflection point is simply where it looks like it's caving this way, and then it starts to cave the other way. So its curvature changes, okay? And then what is the domain of this function? Yeah, negative infinity to infinity. What's the range? Where do you go to find the range? Y-axis. You come down here to the y-axis, and then where's this graph? This graph is going to keep on going forever and ever. So y values are going to go from where? Negative infinity to positive infinity. Okay, that's the range of this function. Intervals where this function is greater than or equal to 0. So I'm looking, where's the graph above the which axis? X-axis. So I'm traveling to find the answer to this one. Which axis do I travel on? X, because the only time I travel on Y is when I see the word range. So am I above the axis here? No, I don't get above the axis until I get to where? 0. So this is going to be, the answer is what? 0 to where? Infinity, parentheses, bracket. Where is this function less than 0? That's where? Now you travel from left to right. Negative infinity to 0. Negative infinity to 0, all parentheses. Where is this function increasing? So what about over here? If I travel from left to right, if I went from here to here, did I go up or down? So it looks like I'm going up here, and then I keep going up. So this is always increasing. So it increases from negative infinity to infinity. If that's where it increases, easy question next. Where does it decrease? There are no intervals where it decreases. If it's always increasing, it's never decreased. Even, odd, or neither? Odd. This function is odd, and you've got that one down. So that should take us. Yeah, sorry. Okay. That what? Okay. So what you just need to get comfortable, once I graphed them, I think reading the stuff, was that pretty straightforward? The questions at the bottom? Okay. You just need to get really comfortable with those questions and what they're asking. You know, domain, range, increase, decrease, where it's greater than 0, less than 0, okay? And you just need to get comfortable knowing what all these functions are. So before we end up here, these are the 6 functions. So which one is this? The V, which is what? Absolute value of x, okay? So this one is what? S squared touchdown is what we call that. This one is what? Egyptian x cubed. This one was Superman square root. This one was what? What do we call it? The wave. This is what we call wave, x to the 1/3. What is this one? Yeah, that's the seagull, x to the 2/3. Did I forget one? I think that is it. That is all. So yeah, so I know it sounds goofy, you know, but like just in your mind, have some way of remembering these things. That's why I do sort of the hand motions and the dance moves that are there. So